So, development of geology. So, studying about the nature of the Earth has been ongoing since humans' beginnings, really. So, its materials such as fossils, gems, its processes such as earthquakes and volcanic eruptions. These studies have been ongoing since we first started to be as humans. However, writing about these events and materials that have been found and have been seen only occurred about, or have been seen these writings for 2300 years with the early Greeks. So Aristotle, the Greek philosopher, as some of you may know, strongly influenced later Western thinking, Western thinking, sorry. So his explanations were not based on keen observations, but on speculations about what he thought. So he said that rocks were created under the influence of stars, and that earthquakes occurred due to crowding of the ground, for example. So this ground would get heated by central fires and escaped explosively as volcanoes. Those were some of his speculations. So unfortunately, they were just that, speculations, not necessarily based on keen observations, but they did have some, initial truth or initial thought into them. So although these explanations may have sufficed for those days, they were still considered authoritative for many centuries after that. And it was not until after the Renaissance movement in the 1500s after Christ that more people became interested and also capable of finding answers to questions about the Earth itself. In the mid 1600s, James Ussher, that was an Anglican Archbishop of Ireland, published a major work about the age of the Earth based on biblical events. So what he did was calculate, based on biblical events, the age of the Earth. So he calculated the age of the Earth to be about 4,004 years before Christ. Again, just based on biblical events. And this work was widely accepted by Europe's scientific and religious leaders when he published it again in the 1600s. So it was very influential in the resulting doctrine, which we called catastrophism. So this is going to be an important term, and you're definitely going to be tested on it. So catastrophism stated that Earth's landscape were mostly shaped by catastrophic events. So canyons and mountains, which are features we know now take many, many years to form, were said to have formed in disastrous and fast catastrophic events followed by periods of calm. So this hypothesis of catastrophic events shaping everything made it easier to shorten the overall age of the Earth, which coincided with Ussher's calculations of the Earth being only 4,004 years before Christ, or to have started 4,004 years before Christ. So against this ongoing idea of catastrophism and against Aristotle's thoughts in a way, a Scottish physician and gentleman farmer, who was called James Hutton, published a work called The Theory of the Earth in 1975. So in this work here, he proposed one of the pillars for current geology. So this pillar is called uniformitarianism. So again, another word that you're going to have to learn, or to at least be familiar with. So uniformitarianism basically states that the present is the key to the past. So we'll go over it on the next slide, so I won't go in too much depth. But this also happened shortly after catastrophism was sort of well understood and well received by the literative and the religious society at the time. So it was very controversial. Okay, so again, uniformitarianism, very different from catastrophism. It said the present is the key to the past, and it states that physical, chemical, and biological laws that operate today have also been operating throughout Earth's history. So what we're seeing today, for example, how we're seeing rivers flow, is exactly how rivers used to flow in the past as well, which means that the current forces that shape our planet have been working on our planet for a very long time. As another example, I'll give you this one. So we can determine the rate of erosion from a hill slope in 100 years, for example. So if we assumed, using this concept, that the same rate applies to any 100-year span through the planet's history for a hill slope under the same gradient and the same soil type as the one that we just found, using this concept definition, it would say that the rate of erosion would be the same for any particular hill slope. However, we know that not all processes work the same way. Not all forces have been in place in the same manner. So probably the rate at which erosion took place in another hill slope, even under the same gradient and soil type, say 3 million years ago, was probably not quite the same as it was 100 years ago. So they do differ, and although the basis for this uniformitarianism idea is very good, and we do use it in geology, is not solely true and not solely based on it. So again, it's very important to understand this concept definition, and it is important to know what processes are ongoing today, so that way we know how they behave and interact in order to understand the past events that have occurred. As opposed to the predecessors of James Hutton, however, the owners of the previous hypothesis, being again Aristotle or James Ussher, James Hutton gave verifiable observations to support his ideas. So this hypothesis that he came up with, being uniformitarianism, was based on true facts, true observations that he observed. So if we go about believing everything that uniformitarianism said, that the present is the key to the past and that all processes happen as we see them today, that would make the Earth very old. It's not exactly sure how old based just on that concept, but we knew that it must have been very old because the processes that we see shape the Earth today happen at a very slow rate. Not at a rate that would correspond to the 4,004 years before Christ formation of the Earth that James Ussher suggested. So using this concept of uniformitarianism was one of the main initial ideas that gave us to understand that the Earth was very, very old. So again, today we realize that although uniformitarianism had a very important resonance and that it is still one of geology's pillars, some of the processes that are occurring in the present may have occurred slightly at a different rate than in the past. So their relative importance from one another and the rate at which they occur now may be different than, say, again, 1 million years ago. So to pick up the example about the hill slope that I was talking about, maybe the rate at which erosion occurred 100 years, the erosion occurs for the 100-year time span on the hill slope could have differed if the erosive agents such as wind or water were stronger or weaker than they were before, or perhaps if the humidity of the environment where the hill slope was differed from the one that it is right now. So the bottom line here is that the present does give us insight into what occurred in the past, but it does not hold true to everything that happened in the past. Based on uniformitarianism, though, there were some things that happened in the past that have not happened within humans' time on Earth, and that are still true to have occurred. So we must remember that some processes occur over very long spans of time, apparently unchanging to our eyes, or some that happen fast and catastrophically. So some of those events that happen fast and catastrophically are things such as meteor impacts. These things happen, again, fast, catastrophically. They have a large effect on life on Earth or even on some of the surface features that we see, but they may not happen often, and they may not happen throughout a species' lifespan on Earth. So those are things that we need to keep in mind, that although uniformitarianism for the most part is right, there are still certain events that do occur catastrophically. And that, again, some of the processes don't occur at the same rate or in the same way that they used to before.